Heat can be transferred by 4 different mechanisms. Conduction is the molecule-to-molecule energy transfer. Convection occurs when energy is transferred by movement of gases or liquids. Radiation refers to energy traveling through air or space in form of electromagnetic waves. And latent heat transfer involves changes of state of water through evaporation, condensation, and so on. Solar energy reaches the Earth through radiation. Solar radiation on its way through the atmosphere can be subject to various processes: transmission, scattering, reflection, absorption, and refraction. Transmission is simply the passage of energy through the atmosphere. It occurs, for example, when shortwave solar energy reaches the Earth's surface, where it is called direct solar radiation. Scattering is the redirection of radiation by gas molecules, droplets, or particles. When solar radiation reaches the Earth's surface after it has been scattered in the atmosphere, it's called diffuse radiation. Scattering is the reason why we can get a sunburn in the shade, why a room is lit in the absence of direct sunlight, why we don't cast shadows outside if the sky is overcast, and why we can see a red sunset. The degree of scattering depends on the wavelengths of the radiation. Shorter wavelengths are scattered more efficiently by the atmosphere. The white sunlight contains all colors of the visible spectrum. During daytime, the path of the sun's rays through the atmosphere is relatively short. Only the short wavelengths of the visible spectrum, the violet and the blue, are scattered. That makes the sky look blue and the sun yellow. During sunset, the path of the sun's rays through the atmosphere is long. All wavelengths, except of the longest wavelengths of the visible spectrum, which are orange and red, are scattered along the way, which makes the sun look red. Reflection is the backward redirection of radiation. The difference between reflection and scattering is that reflected light bounces back with the same intensity and at the same angle as it hits the reflecting object. The scattered light is broken up into various weaker rays, which move into different directions. The reflective quality of a surface is called albedo. Albedo is expressed as the percentage of insolation that is reflected. Dark surfaces have a low albedo. For example, asphalt roads have an albedo of 5 to 10%. They will absorb most of the incoming radiation and heat up. Light surfaces have a high albedo. For example, fresh snow has an albedo of 80 to 95%. They will reflect most of the incoming radiation. The average albedo of the Earth is 31%. Absorption is the assimilation of radiation and conversion from one form to another. It explains, for example, why your car seats or the streets get hot on a summer day. The Earth absorbs shortwave solar radiation, which reaches the Earth's surface either in form of direct or diffuse radiation. This causes the Earth's surface to be heated up and emit long-wave radiation, which is nothing else but heat. Gases absorb radiation to different degrees depending on wavelengths. The gases of the atmosphere, nitrogen, oxygen, carbon dioxide, and water vapor, hardly absorb any shortwave solar radiation, except UV radiation. However, they absorb a considerable amount of the outgoing terrestrial long-wave radiation. This causes a warming of the atmosphere, which is called the greenhouse effect. The atmospheric window refers to those parts of the electromagnetic spectrum that are, with the Earth's atmosphere in its natural state, not absorbed at all. The atmospheric window lies approximately at wavelengths of infrared radiation between 8 and 14 micrometers. Refraction is the bending or the shift of direction of rays. It occurs when light passes from one medium to another, for example, from the empty space into the atmosphere. The degree of refraction or bending depends on the wavelength of the radiation. Refraction causes the color separation or dispersion in a prism or raindrop, because the longer wavelengths of the visible spectrum, the red light, are bent less than the shorter wavelengths, the violet light. This effect can be seen in the rainbow. Each droplet disperses the full spectrum of colors. However, the observer will only see one color from a single raindrop, depending on the angle of the observer's view to the sun's ray at this particular droplet. Due to varying solar angles and day lengths and the attenuation of solar radiation on its way through the atmosphere, we find average annual values for insolation, incoming solar radiation, at the Earth's surface, as shown in this figure. The highest values are found in the subtropical regions. These are the regions where we find the largest deserts on our planet. The reason for that we will understand once we understand global atmospheric circulation.